Diffblue Cover is the autonomous AI-powered coding tool from Diffblue. It writes Java unit tests without human interaction. Custom input is a generic term which describes the capabilities offered to the user for customizing the unit tests written. Tests written by Diffblue Cover genuinely reflect the source code-based logic and are guaranteed to pass. To control inputs which go into unit tests, users can add a YAML file at the root of the Java module being tested. Customization is done by listing one or more Diffblue rules which target parameters, methods, and classes. Diffblue Cover will then use these rules when writing unit tests. Diffblue rules might be redundantly used to change values of certain method parameters. However, users should use them in order to resolve checked exceptions. These are reported in the log file produced by Diffblue Cover, most often with an R013 code. Diffblue Cover works with the bytecode, and as we will see shortly, Diffblue rules are written using the bytecode syntax. This table lists the type descriptors used for Java primitive types, class type, and one-dimensional array and two-dimensional array. There is an uppercase letter for each primitive. When specifying the type of a class, we need to type its fully qualified name with the packages linked by a slash, preceded by an uppercase L, and followed by a semicolon. To describe an array of any type, use one or more left square brackets. Here are a few examples of method declarations in the source code and their equivalent description in the bytecode. Method parameters shown in red appear inside a pair of parentheses immediately after a colon. They are not separated by comma or empty space. The return type, shown in blue, must be declared after the method parameters. Here we have a class named descriptors. It has two instance fields, student of type string and ID of type long. Both of them are initialized using the constructor, and then we have two instance methods. Initial does not take parameters and returns a character, the student initial. Last digit, it takes a parameter of integer type and returns an array list of integers, the last few digits of ID. Let's run Diffblue Cover for the descriptors class and let's see how the methods are reported in the log file. The log file states that 3 methods were found, that is, our 2 methods plus the constructor. From the bytecode description, we understand that the constructor takes 2 parameters, a string and a long, and since constructors never return anything, the return type is void. Here it is important to note that calling the constructor is done using init between a bra and a cat. The initial method takes no parameter and returns a character. Finally, the last digits method takes an integer as parameter and returns an array list. Note how the fully qualified array list type appears between an uppercase L and a semicolon. In this video, we show how to use a particular string and primitive value. We continue by showing how properties file can be used as well. We then focus on user-defined types and show how to include them in tests. There is also an example on how to load and read a text file and eventually use its content in tests. We can even call serialized objects and use their fields. Finally, we explain how factory methods can be used to provide off-heap objects which can be passed to unit tests. In all examples, the POM file must contain JUnit and Mockito as dependencies and Maven Surefire as plugin. Here we have a class named member with 2 string fields and a class named employee, also with 2 string fields. Both classes have a constructor, a getter, and a setter for each of these private fields. We can run Diffblue Cover for the whole package which contains the 2 classes using the command dcover create followed by the package name. In the corresponding test classes, Diffblue cover used a string literal for each of the string fields as arguments to constructors and setters. But what can we do if we want all those string literals to be different? We could use a Diffblue rule. If we don't mind using the same string literal in all tests, we could write a rule as simple as this. We type the fully qualified name of the string class and then on a new line a tab followed by the immediate keyword pointing to the string literal which we want to use. This is how the new test classes look like. Now, what should we do to assign a particular string literal to a certain string field? We can write a new rule, this time adding a parameter keyword pointing to the method parameter which we want to control. Here, for example, we want to use John for all constructor and method parameters identified as name. The new test classes show that indeed we have control over the parameter's name in the constructors and setters of all classes, while the remaining string fields still use the default values given by Diffblue cover. We can go further and assign a particular string literal to a certain method name, which may appear in any class, by adding the method keyword. For example, we could target all methods named setName, which take a string name as parameter, even if those methods have different signatures. The new test classes confirm that John was used when the name parameter was found as a parameter to setName method, but not to the constructors. Can we restrict the usage of a string literal to a particular method name, but only in one of the classes? Yes, by adding the class keyword followed by the class name. Here, for example, employee. Now, John is used only in the employee class for the setName method. Let's see how Diffblue cover works with primitives. Here we have a class named operations. It has two methods which add a few raw primitive types. We run Diffblue cover for the operations class. We can see that the two methods were tested with some default primitive values, but we want to use our own. For example, we could ask 1001 to be used with the add method and 901 to be used with the sum method. Indeed, the two values were correctly used. Let's explore how Diffblue cover works with arrays by writing unit tests for the array processor class, which for now has one method. This method takes a one-dimensional array of doubles, puts it in a stream, multiplies each element by 2, and eventually computes the sum. To test that method, Diffblue cover inserted 4 default primitive values of type double, but let's say that we want to test it with 5 values of our choice. We can write, for example, a rule of a one-dimension array of doubles such as this. Now, one of the assertions uses the array provided, but there is still a second assertion, an edge case should the array be empty. Let's overload the process method with another one which takes two one-dimensional arrays of float primitive types. This method adds up all pairs of elements which can be formed between the two arrays. Again, Diffblue cover made its own choices for the primitive values, but can we control this? Yes, by adding a new rule such as this. The new test confirms that the arrays were correctly allocated in the test. Let's add yet another method, this time with a two-dimensional array as input parameter. Diffblue cover wrote an assertion using a 1x4 matrix, but we can try, for example, a 2x2 matrix. We need to add a rule such as this. Now the assertion makes use of our rule for a 2x2 matrix. We might need to use properties files in our Java unit tests. With Diffblue Cover, it is possible to use them from either the project root or the resources directory. Here we have two classes which use properties files to obtain a uniform resource identifier. They are identical in functionality, but we would like the root props class to use the root properties file and the resources props class to use the resources properties file. We will add two Diffblue rules under the Java util properties class. The first one applies to root props class, while the second one applies to resources props class. We can now ask Diffblue Cover to write tests for the whole package properties. We can confirm that the root props test class uses the URI stated in root properties file and that the resources props test class uses the URI stated in the resources properties file. Let's now comment the two Diffblue rules which refer to properties files. The two test classes were also deleted, and let's run Diffblue Cover again. In this situation, none of the two classes is tested because they don't provide the path to their properties file, respectively. The log file indicates this by an R013 code, which is triggered by a null pointer exception. We conclude that in this example, using Diffblue rules is critical unless the user is happy to refactor the source code. Diffblue Cover allows developers to use their own types in Java unit tests. Let's imagine that we build a catalog of birds for a natural history museum. Here we have a class named inventory whose constructor takes an ID reference and a bird reference. ID and bird are our own types and use a long primitive and a string reference respectively. We can easily get unit tests from Diffblue Cover with the source code as it is. We obtain two test methods, one for the constructor and one for the method used to add entries into a map. These are useful for covering the inventory class, but how can we control the arguments given to the ID and bird constructors? We could of course target the long and string parameters for the ID and bird class respectively, as we saw before, but there is yet another way. We could add factory rules to the methods which call the constructors, with a string literal for the bird constructor and a numeric literal for the ID constructor. The new test confirms that our choices are used whenever the ID and bird objects are instantiated. Diffblue Cover can use text files, but making them available to unit tests can be a little tricky. Here we have a file processor class with two methods. Command lines goes through a list of strings and collects those which start with a hash key. That list of strings comes from the other method, readFile, which is supposed to read a file line by line. We have a file named input text at root level, but how can we make it available? First, we need a factory class, here named FileFactory. It has a static method load, which receives a string, namely the file name, and returns a reference to a file object instantiated with the file name. We then need to add a Diffblue rule for the factory method load, stating the file name and the method under test to which this rule applies, here readFile. Eventually, we can see that the text file was used for testing the readFile method not only for its name, but also for its content. Diffblue Cover can work with serialized objects and read their state when writing Java unit tests. Let's imagine that we run a cheese warehouse. In our records, each variety of cheese has a few attributes such as name, maturity, and availability. Let's serialize one cheese instance using the object output stream. This object is now available at root level. We now look inside testable class where we have three methods. Each of them takes a cheese reference and returns one of the three cheese attributes. We like to test these methods without instantiating another cheese object. The serialized object should be used instead. We need to have a class with a factory method which can read the serialized object. We also need to make Diffblue use this factory method by adding a Diffblue rule. We specify its fully qualified name, the fact that it does not take parameters, hence empty parentheses, and the return type, which is a cheese reference. The test class contains three assertions and all of them use the factory method. The attributes received are those used in the serialization process. We have a 3 modules Maven project with JUnit and Mockito listed as dependencies. Surefire plugin is also listed such that Diffblue can validate the tests that it writes. Let's have a closer look at the 3 modules used in this project. We have model, a module responsible for creating objects which inherit from a certain interface such as school member, for example teacher. However, as we will see, these objects are not instantiated in the typical way. To avoid a garbage collector, they are created as off-heap objects. In the core module, we have a class named coreUtils, and inside it a static method, createOffHeap, which uses reflections to return a reference to an off-heap object of certain type T. The business module contains a class named validator, and inside it there is an instance method validateMessage, which takes an object of type message defined in the model module and checks if its field body is an instance of the school member interface. Let's use Diffblue to test the validateMessage method. Because we are at the root of the project, we need to specify the working directory, that is business in this case. We will type dcover_create, assign the working directory, and then add the fully qualified name of the method on the test. With this occasion, let's also keep partial, that is incomplete, tests. We obtained a complete test, but it is only an edge case which tests that the method returns false when the body field in message remains null. We also have a partial test. It remains an incomplete test, therefore disabled, because while trying to construct a different instance of message, Diffblue threw a null pointer exception. In cases like this, a solution can be mocking using the Mockito framework. More exactly, we want to mock the message class in the model module because a model reference is passed as argument to validate message. Diffblue will take advantage of this mock and use it while writing tests. We only need to add the mock option followed by the fully qualified name of the class which we want to mock. We can now see that our first test was expanded to accommodate the mock and uses Mockito-specific syntax. Instead of partial test, we now have a complete test. On a closer look, we note that this test method instantiates a teacher object which is of type school member, stores the mocking in the MSG variable, and calls the specific Mockito method when they return. That is, when calling MSG getBody, teacher reference will be returned. This is useful because MSG getBody will return the type of the body field defined in the message class. With that type being teacher, we can be sure that the validate message will return true. However, we might not be happy with this test because, as mentioned earlier, Objects of school member type are not supposed to be created using the new operator. Here we can use Diffblue rules. The idea is to make use of the method createOffHeap declared in the core utils class, which is part of the core module. We need to add a Diffblue rule inside Diffblue rules YAML file, which must be placed at the root level of the module being tested, in this case business. This rule targets the teacher type from the model module. It acts by passing a parameter to the createOffHeap method. Here we state that the method takes in a class reference and returns an object reference. Our parameter is a reference to the teacher class. Let's run Diffblue cover again. Although we have the same command as before, the outcome will be different because our Diffblue rule will be considered. Here are the two tests. The first one didn't change since it is an edge case. However, the second one has now used createOffHeap method instead of new operator. createOffHeap method returns a reference to an object of type teacher, and because teacher implements school member, the test will pass with an assert_true assertion. This was a brief tutorial on how to use custom inputs. For more details, please visit diffblue.com.